Hello, everyone. Welcome to this space on Twitter. For those of you who don't know, this is basically an audio broadcast where I'm going to be having a live Q&A with the one, the only Neil deGrasse Tyson. Neil has a brand new book out. Neil, what's your book called?
Oh, it's called Cosmic Queries.
And what is that from?
Oh, sorry, I should finish the whole subtitle of it. So, as most books of nonfiction, there's the title, and then you don't know what the title means until you read the subtitle. So here it's Star Talk's Guide to Who We Are, How We Got Here, and Where We're Going. And one of the formats of our very successful Star Talk podcast is called Cosmic Queries. And it's where our fan base asks questions. And if it's outside of my expertise, we bring in another expert. And then we just blow through them, and it's fun. And I've got Chuck Nice as my co-host, who's a comedian. So he's a force of levity in this. And the content is the force of gravity. And the mixture of those two helps deliver a sort of a consistent package. But some of those questions don't lend themselves to podcast exchanges. Like, why are we here? How did the universe get to be this way? How did it all begin? How will it all end? And so we lifted those up to a book. So this book is like the deepest questions anybody has ever asked ever about the universe.
Cool. Well, we may dig a little deeper into some of those, and we are also going to be open to some question and answer from people in the Twitter audience.
Totally into that. Totally ready for that.
Cool. So if you want to ask Neil a question, you can use the hashtag NeilSpaces. And that's up in the description up top if you can't find it. And I will be combing through those to choose some questions. And we may bring some people up to the stage to ask questions to Neil himself.
Is that the best hashtag you could come up with? NeilSpaces?
It is the most direct hashtag.
Okay.
You could suggest a better one, but I'm not going to use it.
Okay. I'm just wondering, who comes up with these.
Cool.
But
I will
fine.
say, So I'm going to ask one or two questions while we get some questions in from the audience. First thing, just because we're on a product called Twitter Spaces right now, how do you feel that Twitter, of all the things they possibly could have called this, chose your domain? They chose space.
Oh, yeah, that's cool. I like that because space is, to me, when you say space, I'm not thinking about when people say, I need my space or this is my space. When you use the word space, my head is in the vastness of the cosmos. And that's space. Anything else is like the space around you, that's air, right? That's not space. Of course, the air is in space, all right? There's space between the air molecules for sure. But so one of my favorite T-shirts says, I need my space. And it's got rockets and planets and moons and stars on it. So I'm delighted that the vocabulary of astrophysics has once again infused pop culture. And so I'm all in on it.
Cool. Okay, so I'm going to ask my first question, and this is something, I'm going to guess everyone here doesn't know, but I used to work on your podcast, Star Talk, and I've had lots of opportunities to ask you questions, but this one somehow slipped through. So my question for you is, do we know that the laws of physics have always been the same? Like when we look back at the Big Bang, like in that instant, were the laws of physics the same as they are now?
That's a great question. And you might think we're all just assuming it without testing it. But there is a tiny but very real and very committed cottage industry of people physicists, where all they do is check for the stability of the laws of physics and checking to see if everything is happening the way we all have come to expect it to happen and to take place. So, for example, there are people who wonder whether the law of gravity changes slightly in the exact alignment of the sun, moon, and earth, which would be mid total solar eclipse or mid lunar eclipse. When that happens, all three are exactly aligned. And they're wondering, because there are not many occasions to measure it in that exact moment. You got to be there for the eclipse and you need the equipment and you got to be like asking the right questions about it. And so I'm glad these people are there. Now, it turns out, okay, if I can give it, I know this should be conversational, but I have a slightly long story I want to share with you. Okay, so
I'm not
Isaac
going to
Newton,
stop you. Go right ahead.
Isaac Newton comes up with his laws of gravity. Okay, 1687, brilliant work of genius. All right, and he's got the formula, and he says this is, and you plug it in, and this is the moon going around the Earth going around the sun, the planet, the planets going around the sun. He's got this. Not only that, it worked for the moons of Jupiter orbiting Jupiter, right? So he didn't start out saying, let me try figure that out. He found out what came to be known as a universal law of gravitation. And in astrophysics, when we use the word universe, we really mean universe. Unlike on Earth, when they call something a universal joint or Miss Universe. No, that's Miss Earth. Okay, that's an Earth joint. That's an Earth thing. All right. So, or Mr. Universe as Mr. Earth. So this applied out to Jupiter and even to Saturn. But then William Herschel accidentally discovered another planet orbiting beyond Saturn. All right. It ultimately came to be known as Uranus. All right. It's a quick thing.
And when you say Uranus, that is the correct pronunciation?
Yes, unless you're 8 years old. Yes, it's the correct pronunciation.
Just making sure.
Okay. Uranus. Yes. And so, by the way, just a little.
Wait, just Neil, just a quick question. What's the other pronunciation? I don't know which one, in case people don't know what it is.
Yes, we're not talking about my anus. We're talking about Uranus. Right. Okay.
All right.
So, so what happened? So, by the way, no one had ever discovered a planet before. All the known planets have been known since the ancient times. So this was weird because how could there be another thing out there? And he discovers it, and he didn't know what he should name it. Right. And this is what I'm about to say is irrelevant to the story that I'm going to pick up in a minute. But what do you name if no one has discovered one before? So he named it after his principal benefactor, who was King George. This is the same King George of the American Revolution, King George. So, to whom the Declaration of Independence was addressed. And so, implicitly, if not explicitly. Anyhow, so that meant for a period of time, and I have books that detail this, for a period of time, the enumeration of planets in order from the sun was Mercury, Venus, Earth, Mars, Jupiter, Saturn, and George. That's how that was. Okay, so now we're looking at the orbit. You got to wait a little while, get enough sort of data, and you say, oh, Uranus is not following Newton's laws of gravity. Oh my gosh. Have we found the limits? This is back to your question about the Big Bang. That's a time question, but this is a distance question. Have we found the limits of Newton's gravity? Maybe it only applies out to Saturn, and when you're out among the stars and beyond, maybe another law applies. This is how fresh we were thinking with whether physics was an ultimate understanding of reality or not. So, so people said, Newton is a brilliant guy, and I'd like his theory is nice and tidy, and it's worked everywhere we've seen it. Rather than assume his theory is failing, let's do something else. Let us propose that there's another source of gravity out there yet to be discovered that's tugging on Uranus and giving the illusion that Newton's laws are failing. So a bunch of people got together, observers and mathematicians, they got together, and it's a very difficult problem. It's an inversion problem. It's not, I have this object, what's the strength of gravity at this distance? It's, I have this place in space. How much gravity do I need there, and where would the object have to be to create this effect? It's an inversion problem, very difficult mathematics then and now. It's a difficult problem to solve. They solved it. And they said, look, in this part of the sky, if Newton's laws are correct, there should be another planet right there. Bada bing. That night, they turned the telescope and they found another planet, and thus was the discovery of Neptune. Point is, and this continued out to binary stars, binary galaxies.
Wait a second, Neil. Is there any planets outside of Neptune you'd like to bring up?
No, the known universe ends at Neptune.
Yeah.
There's stuff out there, frozen icy balls of, dirty ice balls. Yes, and they have names, some of them. Okay,
you're saying directly outside the orbit of Uranus, there's dirty ice balls.
By the way, I buried the hatchet with Pluto long ago. Me and Pluto go way back, and Pluto can handle it, even if some other people among us can't. Okay. So, by the way, every now and then in my Twitter stream, it's on some other topic, and somebody's got to jump in and say, "You were mean to Pluto." It's like, get over it, okay? Pluto, it's time. It's time to move on, okay? MoveOn.org, okay? Just move on. So, where was I? So, my point is, we've been testing the extents of the laws of physics that we measure here on Earth ever since there have been laws of physics. And fortunately, we do have a time dimension here, just the way the geologist looks at sediments of rocks, and they know that one sediment that formed later than the other is going to be above the other unless there's some kind of subduction or some change in the terrain. You have a timeline that goes straight through all the sediments. That's how we know when the dinosaurs were and when they went extinct and when mammals rose and all of this. We have the same principle in the universe because as you look out, you see things not as they are, but as they once were, because it takes light time to reach us. So you see the moon as it was 1.5 seconds ago. You
So
see this.
is there someone like 1 light year away that could see all of us before we gained all of our COVID weight?
Yes, correct. Yes, the COVID pregnancies and COVID bellies are all pre 1 light year away. There are no known stars 1 light year away. The closest one is Alpha Centauri system. That's 4 light years away. So that one would be seeing Trump just ascending to presidency, and they would be seeing the the Women's March and the Science March right around now. Okay, that would just be reaching them now. So they're looking into the past of their universe, which is 4 years ago for us, as we would be seeing their past. For what I like thinking about is there's a galaxy. I forgot what its phone number is. It might be M100, but there's a galaxy that's about 65 million light years away. They're only right now seeing the asteroid take out the dinosaurs. It's just now arriving. Point is, we're here in our galaxy on Earth, and we look out to the outer reaches of the universe, and we see the same laws of physics manifest. And no, we don't see moons orbiting planets, but we have spectra. We can take the light that it's coming from stars, and in that light is the chemical compositions of the glowing gases that are making that spectrum. The carbon, the oxygen, the nitrogen, and those spectral features are like a fingerprint. They're unique to all the elements on the periodic table and the state of the elements. An ionized element has different lines, different spectral features than a non-ionized element. Okay, so we know how hot it is, what elements are there, in what ratios, and we look out to the farthest reaches of the universe, and the spectral features are identical, which means that atomic structures and the laws of physics that operate inside the atom, the quantum physics, the strong nuclear force, the weak nuclear force, all of those from the earliest moments we could possibly measure in the universe match what we get in the laboratory. So not only are the laws of physics constant throughout time, they're also constant across space. And if that were not the case, I don't even know if we would have such a thing as science, because science has its foundations on the fact that I can figure out what's going on over there by deducing based on the laws of physics that I have figured out over here. And there you have it. That's my answer to your good and simple question.
All right, thank you. Let's get right to some questions from the fans in the audience. I'm going to pop one right up there in the Twitter space. This is from Tony, ILL Physics. What is the most important question you hope the James Webb Telescope will answer about the universe once it's fully operational?
Oh yeah, so that telescope is well. Okay, I'm mainstream here because that telescope is exquisitely tuned to observe galaxies being born in the early universe. And so here's what's going on. Galaxies being born in the early universe, they're very hot. They're emitting a lot of ultraviolet and blue light, except they're so far away, and the expansion of the universe redshifts the spectrum that all of that blue and ultraviolet light has redshifted across the spectrum and landed in the infrared. So the James Webb Telescope here in our portion of the universe is tuned for the infrared signature that is what became of the ultraviolet light emitted by galaxies being born 13 billion years ago. And that's a missing chapter in our understanding of galaxies because all big galaxies have black holes in the center. How did they get there? Did they form from the beginning? Did they form first and then all the stars joined in? Did the stars assemble first and then there was like that's the trash heap down in the middle? Where there's some big uncertainties that remain, and we're waiting for the James Webb Space Telescope to solve those. And because it's exquisite telescope for the infrared light penetrates gas clouds where stars are being born. And so not only will it tell us what was going on in the earliest universe, it'll tell us what's going on deep within gas clouds right in our own backyard, in our own galaxy. So it's going to span the entire universe, and we're chomping at the bit for it.
All right, very cool. Just quickly, I want to remind everyone that Neil has a new book out, Cosmic Queries, with a really, really long bunch of words after it. And you can buy that wherever you get books. And luckily, we are here with Neil right now, and he is answering our questions. So if you have questions for Neil, use hashtag #NeilSpaces, and we'll try to get as many as we can answered. All right, let me pull up another question here from the Twitterverse. How about this? From Ole Sport or JMFR. If we were to make a time machine, where exactly would the machine send us?
if if you're going to make a time machine, I presume you have power over where it will send you. So it's not like it's going to have its own mind. Let's walk in and wonder where it's going to send. No, you'd be stupid to make a time machine where you could not control where it was going to send you, first of all. Second, it's been rumored, by the way, for the longest while, especially when James Cameron's film The Titanic was in everyone's awareness, people said if I had a time machine, I'd want to go back and witness the sinking of the Titanic.
No, if you had a time machine, you would go back and make sure that he got his stars right in the original cut of the movie before you made him change it.
There are more important things I think I would try to accomplish than talking to James Cameron about the wrong sky over the sinking Titanic. But what I can tell you is it's been rumored that in the future someone does invent a time machine, and in fact the people do go back to witness the sinking of the Titanic, and the Titanic got overloaded with people, and that's why it sank. From time travel, it's been rumored. That's a fun sort of time traveler.
How do we know that they weren't just fat people?
It's just
you're on a cruise, you get all the good food.
It is a cruise. I don't know if there was the food barges then that they were today, but okay. So that's my first point about time travel. Second point, during the Science March after Trump ascended to presidency 4 years ago, one of my favorite posters there, the placards, was, "What do we want? Time machine. When do we want it? It doesn't matter." If you have a time machine, who cares when? Because you have access to when. So that was a brilliant sign. But so for me, I would want to go into the future, because what is true for me, as is true for most women who have ever lived, there is no time in the past where you are better off than you are in the present. And add every other oppressed group or disenfranchised group that there has existed in the world. So no, I'm not going. If I went back 100 years, I'd be someone's butler. 150 years, I'd be someone's slave. 50 years ago, no, 70 years ago, I'd be carrying someone's luggage. So there is no time. I have no nostalgia for the past, but I have longings for the future and what it might bring technologically, culturally, interpersonally. So yeah, I would go 30 years into the future, I think, which is close enough for me to grok what they're doing, but not so far that I wouldn't possibly one day still experience it.
Awesome. Just popped into the space. Chuck Nice is here. Comedian Chuck Nice. Oh,
Chuck Nice popped in. Dude, can you hear? He must, yeah, he can hear, right?
Hey, it's, are you talking to me?
Chuck, my co-host on Star Talk, dude.
What's up, Neil?
How you do? How you doing,
Hey, man. How are you?
I talked about you. I said you're my force of levity
well,
when I talk about complex topics.
yes. Well, at least I have. At least there's a science term in there somewhere. Force. so force. I'll take it. It's physics in some way, even if it's levity. This is so cool. First of all,
levity.
I had no idea. I don't know what this is. This whole format, this spaces, but it's really kind of cool, man. I've just been sitting here listening to you, and it's so weird because whenever we are together, I'm like seeing you and talking to you, whether it's in person or over Zoom. And now I'm just listening to you live. And I thought to myself, like, why am I doing this? I can just
Chuck. Now you know everyone that listens to the Star Talk podcast. This is what they need to deal with.
I'm like, I can just call Neil. Why am I doing this? But guess what,
Chuck? You don't want to think of it as a special occasion.
No,
Chuck.
It is. It's really cool, actually. I'm really digging this whole thing. Now, what I don't like, and Ben, I know you're in with the Twitter people. Please, tell them that when you click on anybody's face, but I'm more concerned about Neil. You click it on the speaker, and the first thing it says is block Neil Tyson, report Neil Tyson. I'm like, what the hell is that? What is that about?
Well, you know what? Incidentally, Mr. Twitter, Danny, he's with the research department at Twitter. He just came up to the stage, and he now officially knows that is an issue and that everyone should block you.
That's funny. That's funny. It's your first.
How's it going? And that's actually great feedback. We're building in public and looking to learn things like that is how we can improve the experience.
Yeah.
We're still in beta. So
okay. Hey, Danny, no problem, man. But yeah, get rid of that. Like, you invite me to something and then immediately ask me to troll somebody.
Noted.
It's like in the back of the taxis in New York City. There's the 311 you can call, and it says call 311 to report this
Yes.
driver. It's like it's daring you to do so.
Exactly.
And
All right.
I'm an old time New Yorker, and in the old days, you'd walk down into the subway, and the first sign that was there, and it was old and dirty. It says "No spitting." And it was like,
right, and then right next to it, there's another sign that says "Too late."
All right. Well, hey, Danny, while you're up here, do you have a question for Neil about the universe or not the universe? One of those two options?
Oh, man, I just put my kids to bed. I was not prepared for this at all. But I actually...
But surely you've been harboring a cosmic question your whole life. There's like, how many astrophysicists in the world? There's like 7,000-8,000 of us and 7-8 billion people. So we are 1 in a million, literally. So right now, ask your damn question because you're never going to get this chance again.
I know. I'm just going to go for it off the top of my head. Mars has been a hot topic lately. How likely, how soon do you think that's possible that we can live there?
Okay. So Antarctica is wetter and balmier than Mars. Okay.
And Chuck is wetter and balmier than Antarctica.
How do you?
But no one
did you
lined up to build condos and live on Antarctica. So to say I want to go live on Mars, it's like, really? Like, really? All right. So why don't we build a HAB module? Okay. So let's do that. But then when you go to Mars, then you're living on Earth on Mars, right? Because inside the module, it's got regular air, and you're just a little lighter because Mars gravity is 40% Earth gravity. So you're a little lighter, but everything else is the same. You get great views, but do you want to live there? Why not just make it a vacation? I can picture the future where there's like a Disneyland type park, okay? And with interesting sports, because everything weighs 40% of what it used to. You can jump higher and run faster and this sort of thing. That would be fun, entertainment and different kinds of amusement park rides. So you can do that, but then come back. You don't want to stay there, dude. And wait, and suppose you're worried that we're going to trash Earth and we need another planet. Okay, so then you want to terraform Mars to do that. Turn Mars into Earth. Great word. vocabulary word for the decade. Terraform Mars. You go there, you seed the soils, you seed the atmosphere, you can change the environment. By the way, we talk about this in Cosmic Queries, in the whole book on the search for life in the universe. So you seed it. Now we move 1 billion people there. Okay, fine. I don't have a problem with that, except if you're doing that only to avoid the next asteroid so that humans don't go extinct or the next virus, you put your eggs in 2 baskets. I'm thinking it's cheaper and easier to deflect the asteroid than to terraform Mars and ship 1 billion people there. I'm thinking when we trash Earth climactically and we need another planet, if we have the power of geoengineering to terraform Mars, to turn Mars into Earth, then we have the power of geoengineering to turn Earth back into Earth. So Mars for me is a vacation spot. It's not a destination where I'm going to hang my hat.
Well, Danny, let me just say, don't listen to that naysaying. I have made significant real estate investments in Mars, and I'll send you a brochure, brother. I will send you a brochure.
Thank you. I can't wait to get this timeshare. This is awesome. Well, this is great. Thank you, Ben, Neil, Chuck.
All right, Danny.
And how old are your kids? How old are your kids?
I have a 2-year-old daughter and a 1-year-old son.
Ouch!
And
oh man!
I know.
And you had that all during COVID? Oh my gosh!
And we're trying to build this, so we're doing our best out here, man.
Hey, good.
Wow. Okay. All right. Well,
All right.
Power to you.
Thank you, guys. Thank you so much.
All right,
Take care.
All right.
So much, Danny. All right, let's push right on to our next question. This is from Marissa. She has read that black holes are far more pervasive than previously thought. Do we have a reason to fear them more?
Always fear black holes. Next question. No, I'm just saying.
There you go.
So what you ultimately would need. So the scariest thing is a black hole that's not being orbited by anything. Okay, because if it's being orbited by something, you can say, "Hey, why is that star making loop-de-loops and there's nothing inside the loop?" Oh, there must be a black hole there. So you can infer the presence of the black hole. If stars get too close to a black hole, the black hole flays the star, stripping it of its outer gases, and you can see a highly radiant spot where the material is heated by friction as it spirals down into the abyss. Then you say, let's avoid that. But if you have a wandering black hole with nobody in its vicinity, that you can end up stepping in it, and that would be bad for you. So yes, so we need some sort of black hole detectors. There are ways to do it because they distort the imagery behind it because of the fabric of space and time are curved. So if you're going to go through long interstellar voyages and you want it to be really, really safe, you bring in black hole sensors and then you just go around them. They're not vacuum cleaners trying to suck you in. And Chuck, an old joke that we used to say, there's no such thing as gravity. Earth sucks. I don't know if you knew that. That's one we told in high school. So anyhow, they're not giant vacuum cleaners, but you don't want to get too close to them because then you will never escape them. So yes, you need black hole sensors for your interstellar journey going forward.
So the black hole without anything orbiting it is kind of the cosmic equivalent of black ice when you're driving.
Yeah. Sure, except black ice, you'll skid across and come out on the other side.
Right.
Whereas a black hole, you fall in and never come out. So other than that minor difference, yes, they're exactly the same.
Yeah, that
it'd be cool if you drove onto black ice and then the car nose dove into the pavement and then you never saw it again. Then that would be a closer analog.
Yeah, well, and it would also make me hate the fact that they call it black ice even more. Because, by the way, ice is white. Okay, people. All right. So
why is everything got to be a black thing to you?
Because I live in America. That's all I'm saying.
I can't talk about anything in the history of the world if it's bad and it's black. Chuck is just there's the Black Plague in the 14th century.
And why I got to be black? Okay, that's all I'm saying. Why I got to be the black? Why is really? Okay.
I am not taking part in this part of the conversation.
That's right. Benjamin Ratner, yes. Okay,
let's move on to another question.
Yes.
So this one here is from let me pull it up here. It's from someone JK at JK something. A lot of words and letters. Neil, Can you explain the general theory of relativity so that a layperson could understand it? What is space-time?
Yes. Oh, sure,
Cool.
sure. So matter tells space how to curve, and space tells matter how to move. Therein is general relativity.
And you know what? Here's the
Oh, you want more
problem. Here's the problem. That is so. I mean, and seriously, that is very like beyond eloquent. It is also elegant what you just said. It is not just eloquent.
It had a little bit of too much haiku,
Yeah,
maybe, but
it's not just
I don't know.
eloquent. It is also elegant. But the part of the question that I think you missed is he said so.
What part did I miss?
That a layperson can understand.
Well, I thought, okay, so I'll add another layer.
Chuck, just because you don't get it doesn't mean a layperson don't get it.
So what we learned after Newton, gravity was action at a distance. Mysteriously, Newton was upset that he could tell you that the moon and the earth attracted each other, but there was nothing in between. There was no rope, there was no chain, so he was a little disturbed by that, a little bit unsettled, but he knew his equations worked. So he was comfortable in that fact, but not comfortable in the fact that here's this gap and he doesn't know how to bridge it. So Albert Einstein comes along and says, wait a minute, it's not really a force at a distance. No, it is that matter and energy, because they're the same thing, E equals mc squared, any concentration of matter and energy distorts the fabric of space and time. So what you think is just empty space actually is a textured fabric. All right. And so here you are, you have a mass out there, it bends the fabric towards it. Now here you are traveling through space, minding your own business, and you find yourself leaning towards where the bend is in the distorted fabric of space and time. And the denser is the object, and the stronger its gravity, the deeper the distortion in the fabric of space and time. And a black hole is like a throat that goes down and there is no coming out. Now, so what that means is a beam of light would curve along that distorted space and time. And light travels the shortest distance between 2 points always. And so in curved space-time, the shortest distance between 2 points is going to be the curved trajectory along the curved fabric of space and time. So if I can get sort of automotively geeky on you, okay? There's an old joke in where is it? In Charlotte. Where's the headquarters of NASCAR? Charlotte, right? North Carolina. So they say, you joke with one of these NASCAR drivers and say, oh, do you only know how to turn left? Okay. Because the oval's all, okay. So they got it wrong. Okay. Do you realize the bank of the track, there's a speed with which you can drive so that when you enter the bank of the track, you never have to turn the steering wheel, because the speed of your car and the bank of the track are exactly combined for you to follow the fabric of that space-time continuum, which in that case is a NASCAR track. So you can drive the entire track in an oval and never turn the steering wheel.
That's the laziest possible way to drive.
Yes, it is. So that their actual steering is when they maneuver around each other, not really when they're going on the bank to turn. It's mostly because they're trying to maneuver for position. So the banked oval is like the curvature of space-time in the universe, where light will travel that no matter what, and a car will bank that turn and end up going back in the other direction, even though you never turn the steering wheel. That's my automotively geeky analog to Einstein's general theory of relativity. That's not in the book, by the way. Okay.
Well, I'm glad we got to hear that.
In Twitter Spaces. Oh, by the way, until today, like for the last week, Amazon was out of stock of the book. So the book came out like last Tuesday, and they went out of stock Wednesday morning. It was like, what the fuck? So they finally got stock back in case anyone was like waiting in line for it.
Is it rough having so many bestsellers?
No, I don't have that. I have a few, but no.
Neil, you just said you have a few bestsellers.
Okay, sorry. Okay, it's a few, but it's not all. I have 15 books, and maybe 4 have been on the bestseller list.
Yeah, you know what? That's worse than an F. You're a failure. I'm sorry I even brought it up.
No, one of them did really, really, really well, and that was Astrophysics for People in a Hurry. And someone said, well, is that Astrophysics for Dummies? I said, no, that title was already taken. But it's actually not for dummies. It's like this real astrophysics in it, but it's short and to the point. And if you're in a hurry and you don't have time for fat books, Cosmic Queries is a fat book because you cannot shortchange the question, why am I here and what is my place in the universe? You can't do that. And how will it all end? I give you all the scenarios of how the universe will end. The scariest among them to me is the Big Rip, but I'll only answer that if somebody asks. So go on.
Is that about a fart?
No. Okay. You mean to rip one? No. It's worse.
Oh, okay.
All right, what else you got?
Okay, I'm going through the pictures right here. The pictures, the tweets. I was going to invite someone up and they disappeared. So they are catching me off guard here. Let me see if they came back here. I really know how to kill time, don't I? Let's see here.
While you're searching, I can just talk about the universe. It's a vast place.
Sure. What's
actually?
Hey.
Just while you're searching, I got one.
Wait, can you hear
People
me?
have heard about this.
Unfortunately,
I'm back. Unfortunately, you know what, Ben? You son of a.
Ben, I thought you got rid of it.
I know you put me off, Ben, but I'm back.
Back in the
face. Hey. So while we're vamping, I just got to tell you a really cool story that happened to me this morning because I was on a climate summit with the University of Colorado, and they say, "Hey, can we take some questions for you, Chuck? Do you mind answering some questions?" I'm like, "Sure." And of course, inevitably, the question comes up: what is it like to work with Neil Tyson? I'm like, aren't we here to talk about climate? And but the cool thing is, I told them the story of when we were chilling outside at night, and Neil has people. I got to put you on blast, bro. I'm sorry. Neil has this illegal thing. It's a laser pointer or something, but it's totally illegal because it touches the cosmos. Like, he can point at a star and the laser pointer actually touches the star. Okay, it's really ridiculous. But anyway, we're like chilling, drinking wine, and he's actually being the Hayden Planetarium in person. And it was like one of the coolest things ever. Because
well, if you're out under the real sky, you can't forego that opportunity. If people are there and we're all looking up and we're just chilling and it's dark and there's stars above, I'm going to talk out some universe.
This is true
when that's happening. And the laser's not entirely legal, but it's I'm director of the planetarium of a planetarium.
Oh.
So if you give me the laser, like the laser pointer, and I got the dome, then I get into my planetarium voice, and now the cosmos above.
Yeah.
In planetary director school, there's a whole class just on your voice coming from the sky. This is just that.
Well, okay. I got a question for you, Neil, from Dr. Aktubi. Hey, Neil, does time stop if we could stop every movement of the universe?
Okay, that's a great question. And I thought about this from childhood, I remember, because every measure of time that we have involves something that repeats, right? So seconds or a clock or something vibrates. And I thought to myself, if nothing vibrated, would there be time? And so if nothing repeats, then there can be no measure of time. But that doesn't mean there is no time. So the only thing that would matter, if nothing repeated regularly, is the sequencing of events that you witnessed. So you could say, this happened before that. And that would have meaning for you in your life and in your perspectives on the universe. And so you would just sequence it. So your books would just be written, this happened before that. You wouldn't assign a date to it that involved repeating years or repeating months, days, hours, minutes, or seconds. So there's no reason to think that there would be no time. Only the measurement of time would go away. There you have it.
All right. We got another question here. Let me pull this one up.
Oh, by
Many
the way,
people ask about.
just while we're there,
Yep.
okay. You cannot know the variations. You cannot measure the variations of something unless your unit of time is smaller than the unit of variations you're trying to measure. Now that's what I just said there is deeply profound in the world of physics. So, for example, the rotation of the Earth used to define the day. How long is a day? It's one rotation of the Earth. Okay, can't get any better than that. Oh, yes, you can. Let us offload the measurement of a day, which is 24 hours and 60 minutes per hour and 60 seconds in a minute. 60 minutes in an hour, 60 seconds in a minute. Let's offload that and now precisely identify the length of a second. So now you go into an atom, the cesium 137. There's a transition of electrons in the energy levels, and then you count up how many of these you define that you say that's the second. Now it's not dependent on the Earth. So how many seconds are in a day? I think 86,400 or whatever the number is. And you count that out. When we started doing that is when we learned that Earth is slowing down. We need leap seconds to make up for the fact that Earth is slowing down in our rotation. You could not have even known that unless you had a more precise measurement of time than Earth itself. Otherwise, your very measure of time would be changing and there'd be no way for you to know it. So that's deeply philosophical, but it's important. And this is the underpinning. If you want to look under the hood of what we do in science and physics in particular, that's the kind of stuff that's going on behind the scenes.
So,
all right. Yeah, I have a question. So you're talking about how time, like how the way we define time is different. So let's say Elon Musk gets a human colony to Mars in 2026. This is a question I actually heard for the first time on Hank Green and John Green's podcast, Dear Hank and John. How should the Martians, I suppose they might be called, how should they live their lives? Should they be on the Martian clock? Should they be on the Earth clock? Are their times of day going to be different? Are their computers going to work differently?
Yeah. So wait a minute, Neil. Before you do this, let me just hand. If it's 2026, they should be on the Jack Daniels clock, because quite frankly, to live on Mars in 2026, you got to be drunk.
So it's Jack Daniels o'clock.
Exactly.
Not a sponsor.
Jack o'clock. All right.
Go ahead. Sorry.
Give new meaning to Jack o' lantern, right? It's just Jack everywhere. So here's the thing. Our time is measured to match how we live. Okay. So our year is cued off the seasons. But you realize there are 3 other possible year lengths we could have used and did not. Okay. Because those other years do not coincide precisely with the change of the seasons. So we have a season clock. A season, we keep track of a year based on seasons. Okay. And by the way, so that's not the time it takes Earth to go around the sun. The time it takes Earth to go around is slightly different from the time it takes us to repeat to the vernal equinox, which is a fiducial metric for when you begin an astronomical calendar. Okay. It's the timing from the vernal equinox, which is the first day of spring in the northern hemisphere. So the time it takes Earth to go around the sun is slightly different. All right. So you could do that. We could have made calendars of the time it takes Earth to go around the sun, but then other things don't match up with that. And the first day of spring would migrate through the calendar and it would end up in April and then May and June, July, August. And it would just completely cycle through because we wouldn't care about it. We care about when we show up on the same side of the sun, in that being our definition of the year. But what good is that for us? We don't live according to that. We live according to the seasons. So sensibly, our years are indexed to seasons. Sensibly, we evolved as mammals in a world that has day and night. And our circadian rhythms, by and large, match the day and night cycles. So a day makes sense to us. We could have defined a day to be 36 hours. We could have. Okay. But what would that mean for you? You'd be sleeping at different what? What you wouldn't sleep at the same time interval in one 36-hour frame compared to the
No, it
other?
mean you're in
Because you
Vegas.
really want, unless you're in Vegas, exactly, or in a one of those malls where there's no clocks and there's no windows, right? And, the betting halls for like you said. So Mars, you ask, what do people in Mars care about? Do they care about seasons? Mars goes through seasons. Mars' axis is tipped like Earth. Mars has polar ice caps. Mars has winter, spring, summer, and fall. Mars rotates about once every 24 hours. So you wouldn't have to adjust much to the Martian day, but the Martian year is much longer. So if you really like birthdays, you're going to have fewer of them on Mars, and just deal with it, right? But otherwise, or you do what they do for the astronauts. The astronauts queue off of Houston time, mission control. That's what time it is on the space station. It's the time in Houston. You pick. It
All
really
right.
doesn't matter. It's all arbitrary.
Well, we'll let it continue to be arbitrary then. I had a lot of people tweet in when we were talking about the Big Rip, and as per your request, they asked what the Big Rip is.
Okay, all right. So in this book, so just to be clear, normally I am telling people what I think they would and should know. That's what's going on in most of my books. The difference between that and the cosmic queries construct is I'm responding to the curiosity of others. So this book has questions that have been asked throughout the millennia, and they're in this book addressed whether or not we have a good answer for it. So some of it we have excellent answers. We're good. It's in the textbook. The next other kinds, it's like, this is the best I got for you. Okay. And others, there are questions we don't even know if we are asking the right question. So this book was not written based on what answers we had. It was written based on how deep the questions were that humans have asked throughout the history of civilization. And one of them is, how will it all end? So that chapter, there's like a half dozen, 8 scenarios where we don't know which of these scenarios are going to win out at the end. But one of them is the Big Rip. And to me, that was the most terrifying, just to go through this and get the math right. And it was like, I could not sleep once I finally wrote this out. Okay, so here it is. Ready? We all know we're in an expanding universe. In fact, it's accelerating. All right. That acceleration will continue to gain power over all the other forces of the universe. And in the not so distant future, by the way, it's already gained power over the most distant galaxies. That it'll accelerate them out of our horizon so we can no longer see them. As this continues, it'll accelerate every single galaxy of our night sky out of our horizon, thereby forever hiding any history of Big Bang cosmology that anyone could derive in apocalyptic Earth. If people rise up and they look up at the night sky and they see there's only stars there. All right. So as this continues, it will eventually start ripping apart stars from our galaxy. Then it'll start ripping. Rip is the wrong word. It'll stretch the space between the stars within our galaxy and send the stars beyond our horizon, then the planets beyond our horizon. And as this continues, its power will get greater and greater and greater until it starts separating atoms from each other. So it'll start breaking apart molecules, and molecules will scatter to the horizon. And then all you're left are particles. And then the power will become greater than the forces, the strong nuclear force that's holding the particles together. And it stretches those apart. Now you get, and this keeps going until you get to the fundamental quantization of the space-time continuum itself. It's called the Planck length. And if it stretches that, there is no way that unit, it's like the pixels of the universe. It is the fundamental unit that all space-time is made of. Once you get to that, the fabric no longer has any stretchability left. Yet this force will continue to act. And the only word we can come up with is that no, it will no longer stretch. It must tear. And I lay awake at night wondering what that even means. If you tear the fabric of the space-time continuum, what do you see through that tear? What comes in through it? What is it? What does it even mean to pose that question or to take it to that limit? And by the way, we know when that will happen. Okay, in about 10 to the 30th years, long into the future. Nothing you got to
So
worry
why
about.
is it keeping you up at night?
Yeah.
With all due respect, Neil, you gonna be dead.
Yeah. And by the way, I
Okay.
think you should rename it from the Big Rip to "See Ya Bitches," because that's really what's happening.
That's what it
Yeah.
is. That's the end of the thing, the end of the line, and it's one scenario that presumes that the the dark energy. This is the stretching, accelerating force on the expansion of the universe. It's really a pressure in the vacuum of space. Which the more vacuum you have, the stronger it is relative to everything else that's trying to keep it together. And so that's why it gets as it gets stronger, it gets even stronger, right? So the acceleration accelerates, if you will, and so it'll happen in 10 to the 30 years. There's some reasons to think that it might something else will kick in, or that might go away, or something else that we should worry about more happens before that. So all those scenarios are explored in that chapter of the book. So it's mind blowing, really. And I'm just if you want your mind blown, there it is.
All right. So speaking of blowing, and we only have about 8 minutes left, so I want to make sure we get the really, really important questions
I'll give
answered first.
soundbite answers. I have the capacity to do that, actually. So go ahead, go.
Okay, this is from Katie Notopoulos. How is it possible that your farts can feel hot when they're kept in your 98.6-degree butt?
They're only hot when they come out. Okay, yeah, you don't feel them. Well, yes, you know they're inside. If they feel hot inside, you've been eating too much spicy food. But but what's happening is the skin on your buttocks is not the same temperature as the inside of your body, because the skin is in contact with your clothes, and your clothes are in contact with the air. And unless you're living in Texas in the summertime, the air is going to be cooler than your skin temperature, which is itself cooler than your body temperature. So the 98.6-degree sulfur dioxide gas that smells like rotten eggs, as well as methane and some other flammable.
And New Jersey.
Okay, as that comes out, it's trying to get through, and it moves through the fabric of your clothing, and then it increases the temperature of your clothing, and then your skin feels that, and that's why your own fart feels warm.
Now, maybe there's something wrong with me medically, because all of my expulsions actually feel cool and refreshing.
Chuck,
See you,
Chuck needs a
doctor.
species check. We need a species check in aisle 3 on Chuck.
All right, let's pull up another question. Speaking of, well, I'm not going to make the transition I was going to. CB asks, does the size of black holes determine the size of an object it can eat? Could a microscopic black hole swallow a planet, for instance?
So what happens is the microscopic black hole doesn't swallow the planet whole. No, it'll start eating away at anything that was close enough for it to eat. And it's possible that it could eat out a pocket within the thing so that nothing is close enough for it to overcome. Like I said, they are not vacuums. All right. Okay. So, but it's generally bad to be in contact with a black hole, because what will happen is stuff on Earth is sort of attached to itself. The rocks are touching other rocks and things. So generally, a black hole that's smaller than you are can easily eat you, but it won't eat you whole. It will flay you first. and you'll end up descending as this stream of atoms. That's why you end up getting spaghettified. That's how the black hole not only stretches you head to toe, but you become extruded through space like toothpaste through a tube. So you get stretched head to toe, squeezed side to side, and what you look like is a strand of spaghetti as you descend into the abyss. So that's how it manages to consume you if you are bigger than it. There it is.
All right, we got 5 minutes left. Let's get some quick questions, as many as we can in the next 5 minutes. From Aaron, my 10-year-old wants to know, how did all matter exist before the Big Bang?
Oh, okay. So there's a whole chapter on that. Read the damn book. Okay, go.
Well, that's about as quick.
That's how you
That's
plug.
a quick answer, buddy. That's a quick answer. There you go.
Because there's a whole chapter on how did it all begin. And no, I'll address it just briefly. Okay. So you're thinking of matter like it's a thing, but matter and energy is a thing. Okay. And so so there's a limit to how much you can cram matter while it stays matter. But above a certain pressures and temperatures, it becomes pure energy. You can cram that into a tiniest volume ever. Now you want to know what was around before we had that concentration of energy that then birthed the universe, later also becoming matter. And there are ways we have come to understand that. And that's what gave birth to the concept of the multiverse. Because the energy infusion that makes one universe, there's no reason to think it wouldn't make an infinite number of universes, and that's the multiverse. And these are universes and by the way, there are universes that have the same laws of physics. So you could be there having a conversation just like here. All right. Your twin, you wouldn't know it, but they'd be there. There are other universes where the universes would have slightly different laws of physics. Those would be really dangerous to visit. You want to flip a coin across that proscenium, see what happens to it. If it decomposes and it melts, or it vapor, whatever, just then don't go, right? Because you exist in this universe in a form that is exquisitely enabled by the laws of physics that you evolved in. And the creatures in the other universe, who the hell knows what they look like? Hollywood is yet to go there, by the way, to go to a multiverse with different laws of physics in a sci-fi story. So anyone out there in this audience who's got the chops to write such a story, go for it.
All right.
Keep them coming.
This question is from Shiraz. First thoughts that go through your mind when you see a tweet about flat Earth.
Oh, so I think to myself, wow, this is evidence that we live in a country that protects free speech, simultaneous with evidence that we have a failed educational system. That's what I think about. Wow. I can't get angry with them, because they believe they are onto something, and so they're missing something in their education. And I feel bad because I'm an educator, and so it means we need to revamp something's going on in the school system. Why is it that people are overjoyed when school ends? All right, Alice Cooper has the song "School's out for summer, school's
forever."
Out forever. It is a rock anthem celebrating the end of school. And I'm saying, if they taught school right, you would be sad at the end of the school day. You would be sad at the summer vacation. You'd be sad on graduation day. So something's wrong. That's got to be fixed. And if we become lifelong learners and curious, you will learn how to ask questions. You'll learn when you have sufficient evidence to move on, because being skeptical is not, let me doubt everything. It's, let me understand when there's sufficient evidence and when there isn't. Because it's possible to believe you have such an open mind that your brains spill out and you lose all capacity to judge what is objectively true and what is not.
So now let me just tag that by saying this. What you just heard, people who are listening, are the noble inner workings of a scientifically literate educator. And all of Neil's colleagues pretty much talk just like that. So now let me answer the question for real. Because they're dumbasses. There you go. All right? Okay. Dumbass, because you're a dumbass. Because we got pictures and we got all kinds of proof, but you just want attention and you're a dumbass.
All right. I don't want to end on a note of calling everyone a dumbass, so let's get one last question in before
One
we
last
go.
one. Let's do
By
it.
the way, it wasn't everyone. It wasn't everyone.
From Nicole, how does Earth not lose energy if it experiences a constant change in direction on a circular path?
So because there's a constant force acting on it. So a force can do two things. It can speed you up. That's normally what we think of when you press the accelerator pedal. But a force will also change your direction of motion. It can do both things. So Earth is in such an orbit, if it's a near perfect circular orbit, where all of the force that the sun is imparting on it is going into changing its direction of motion, rather than speeding it up or slowing it down, because you can put a retarding force on something as well. So that's why. And there's nothing blocking the Earth, impeding its movement. So Aristotle got it completely wrong when he said things in motion tend to come to rest. No, things in motion tend to stay in motion unless acted on by an outside force, and that is Isaac Newton's one of his 3 laws of motion. So yeah, in space you can move forever. And why are we slowing down in our rotation? Because the moon is tugging on us. You know the tides? You sit at a beach and you see the tides come in and out. That's not what's actually happening. What's happening is you are rotating into a pre-existing tidal bulge in space caused by the moon. So when you say it's high tide, low tide, it's coming in and coming out. No, you are moving into high waters and then back out of high waters. Now, because you are going through the tide that the moon established for you, the friction between the water and the ocean floor and the beach, the beachscape, creates friction against the rotation of the Earth. And we are slowing down, and every now and we've had to add 24 leap seconds since 1972 just to account for this very fact. And one day, when the moon succeeds completely, we will only show one face of the Earth to the moon, the way the moon today only shows one face to us. We slowed down the rotation of the moon effectively, very effectively, in the early relationship between the Earth and the moon. So that's why there's a near side of the moon and a far side of the moon. You've never seen the far side, except through photos taken by astronauts. One day we will each show each other's face, and that'll what's called a double tidal lock. And I used to wrestle, and I invented a wrestling move called the double tidal lock. Just thought I'd tell you.
You're so talented, Neil.
Nothing to do with anything. But hey, with that, you need a wrestling move with a double. By the way, it was collegiate wrestling. It was not like pro wrestling, just to make that clear, just in case anybody wondered. That's what that is.
We've all seen the pictures, Neil.
No, I don't know.
Yes, we get the wonderful picture of you in a singlet out of, actually, I still sleep with that. I still sleep with that. And
as I said, that was 40 pounds and 40 pounds ago and 40 years ago. Right. That's when that was.
There it is. I just popped it up in the Twitter space for those of you who, for whatever reason, haven't seen it. Neil, I cannot thank you enough for joining today. You answered a lot of great questions.
Well, I'm happy to have helped you inaugurate a Twitter space. And I take it back. Twitter space is a great term for it. And so good luck to that. And really, isn't it just trying to compete with Clubhouse? Really, isn't that real all that's going on here?
I'll let you pontificate on that, and I'll let them figure out how to put that into a commercial. Anyway, make sure to buy Neil's book, Cosmic Queries. It is apparently available on Amazon and other places that aren't Amazon. And Chuck Nice, comedian. Chuck Nice, thank you so much for joining as well.
Yeah, man. And
Chuck, you tweeted Chuck Nice Comic.
At Chuck Nice Comic. Yeah, feel free to follow me if you're so inclined. Thank you.
Mm-hmm. Mm-hmm.
And if you want to,
if you're dumbass, you can't follow Chuck.
Oh no, I take everybody. I take everybody. If you're a dumbass, please follow me so I can call you a dumbass to your face.
Yep. And if you're a dumbass that also wants to follow someone who's neither a comedian nor an astrophysicist, feel free to give me a follow. But I guarantee you there will be nothing of value in my Twitter feed. So let's stick to Chuck and Neil.
All right.
Thanks,
All right,
everyone,
dude.
for joining. Thanks for listening. And I would say we'll see you next time, but there is going to be no next time. So just, I'll never see you ever again.
All right, great job,
All
Ben.
right, you
Bye,
got it.
everybody.
Bye.